Alright, can you believe it? You guys are almost done with the first chapter, and this marks the ending of actual unit in descriptive statistics, where we have fully analyzed categorical and quantitative variables in descriptive statistics. After this, we're just going to go a little deeper into how we analyze the mean and standard deviation and what we can do with that in terms of percentages, because we've already done some percentages here. And then we're going to actually come back and we'll end the time by going over sample design. So by the end, of course, research questions, we'll work on that as we do the final project. Actually, we're going to do a mini project right now, so that'll be the beginning of understanding a research question. We will go heavily into sample design in what we call 3A and 3B. And then we've just covered all of this stuff and all of this stuff, and then we can add percentages. So we can add here 25%, because that's pretty much all we can do is add 25% or multiples thereof. Whereas over here we'll be able to do something fancier, and we'll learn that just before the test. So we'll have completely fleshed out this nice flow chart for us. But we first had to slosh through this homework. So I hope that you guys worked with me on this. This is a growth mindset. Just think of how much you knew about statistics before starting this homework. Think about what Chapter 1E was like. You were just making a histogram. That's it. Now look what you're doing. So yeah, I kind of threw you in, but I warmed you up for a few weeks and got you ready for it. So hopefully you've learned a lot, and yet you feel a little bit damaged. That's fine. Now what I'd like to do before going into the next part, which is going to be a culmination piece, I want to take a little practice. This is a focus on medians, and we're just going to use this example as a way to kind of go through our flow chart. So our flow chart begins with a research question. And so the FDA is trying to test 2 new brands of aspirin, and they're trying to figure out, which one's better in the end, which is the better brand. So our research question is that. Our sample design and to collect the data comes next, and you can already guess where we're going, right? We're going into box plots, which is probably going to be around in here. So they are looking at 20 tablets, so that's kind of important because the 20 tells you the sample size. Do you know how many data points are here? Do you actually know how many data points are here? Well, if there's 20, how many are there total? 20, right? So how many are there below this line? How many are there in all of this? Right? And how many are in all of this? What percent is in here? Exactly 25%. And in here is also 25%. And in here is 25%. And same thing here. Now this might not be hard to see because they're all even, right? But what about here? How could you have the same amount here, or here? How could you have the same amount here as you do here? Well, how many are there if there's 25%? What's 25% of 20? So here we go, slow down. 25% of 20. Why? Because there's 20 tablets, so N is 20. And here too, N is 20. It's a different one for brand B. But it's also 20 tablets, different 20 tablets. All right, so what's 25% of? Well, of means multiply. So what's 25% times 20? So how do you multiply percents? It's a good thing to know in life. You multiply percents by turning them into decimals. So 25% is 0.25. So 0.25 times 20 on your calculator is 5. So we've got 5 here. Right, so 5 here. How do I fit 5 in such a small space here? So, I probably just got to stack them. 1, 2, 3, 4, 5. I probably don't have much other choice. But how do I fit 5 here? Oh, I can spread these out all day, right? 1, 2, 3, 4. I have a hard time, right? I have to really stretch it. 5. Well, how do I fit 5 here? Well, I don't know. Maybe I have 1 above, 1, 2, 3, 4, and maybe another 5th one. And how do I fit 5 over here? Well, maybe the same kind of thing. Maybe there's 1, maybe there's 3 here, and then there's 4, and then there's 5, something like that. We can actually look at the shape of what this looks like, right? Do you think this is skewed right or left, or what do you think? And what about here? What do you think the shape of this would be? Good, it is normal. Shape of this is probably, we don't know. It could be shaped like this. It could also be kind of more shaped like this. even all the way. You know, there's 2 or 3 here, 2 or 3 here, 2 or 3 here, 2 or 3 here, all the way across. We don't know, but I'm assuming because we're trying to hit 1 gram, these are 1 gram tablets, we're trying to hit 1 gram, that there's probably a lot of data points in the middle. So it's probably 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, right? 2, 3, 4, 5. So it kind of is going to be a little bit more spread out than what we originally thought, but a nice gentle distribution. So what did I just do? Exactly, we soxed it. What's the shape, right? This is pretty normal. This one looks pretty skewed left. Any outliers? Probably not. The center is the same, although this center looks a little bit off. And the spread, both of them are kind of spread out. This one maybe is a little tighter. This one definitely has some bumps going on over here. So what's the median of each of these? Well, the median is the middle line. It's where the middle of the data are. It's the middle of the data set, of an ordered data set. So if I look at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then in between that should be the median. So the median is, of course, 1 for brand A, and it's also 1 for both for brand B. Okay, approximately what percent is contained in more than 1 gram? Well, we just answered that. What percent is here or more? All right, yes, for A it was 50%, but then also for B it's 50%. So they did a good job. Both companies got the center to be at 1, right? And that's the goal. What's the shape of each distribution? Okay, we already answered that. So A's was normal, maybe, but definitely symmetric, I would say. It'd be very, yes, you could be asymmetric here, and I could show you why, and that's why we don't like box plots, that's why I like histograms, but you can tell if things are skewed. You can't tell if things are normal with box plots, but you can tell if things are skewed, and so I would say B is less normal, so I would probably say a slight left. The only reason I say slight is because here, this didn't go off too far. If this was longer, see, this was long. If this had also been long, sure, but this was short, so that told me that there's probably 2 bumps of data. All right, if government regulations specify tolerances, okay, we're going to skip this one because it's tolerances, which is a better brand, and why? Oh, who knows? So you might say A is more consistent, but if you were really scared of getting too much aspirin, B might be better. But if like anemic, right, then maybe you want to choose brand B. Why? Because brand B, 75% of brand B is what? Below 1.05. That means 75% of the time you're getting less than 1.05 grams, whereas brand A, it's a little bit more even distribution. Sometimes you'll get 1.01, 1.02, sometimes you'll get much less. So if you're anemic and you got to like watch your, you don't want to get over, you don't have over aspirin, then maybe brand B. So it kind of depends. All right, so that was a warm-up, a nice little 10-minute warm-up to get us into the zone for our mini project. So again, this is something I used to do in person, and that was really fun. And then you do it at home, and of course you are going to do this at home and turn it in. So the end result will be turning in this document, and you can literally write on it here. So you'll write on this page. You'll make a graph here, you'll explain a couple sentences here, you'll put some data here, you'll make graphs here, you'll write some answers here, and then you'll write just a couple sentences. People write a lot here because I have a lot of space, but you'll just write a couple sentences here. There'll be 2 ways to do this. One is to just kind of copy what I do, which is totally fine, and one is do it yourself. There's just a few people who actually like doing stuff on their own. They're either creative or they just have their own questions and they want to work at their own pace and they just want to learn it themselves. Then there's another group of students who's like, you know what, I want to get an A in this course, so I'm going to do it all myself anyways because I got to nail it. But you don't have to. And if this week is a hard week for you, there's parts of your life or whatever, just follow with what I'm doing. It's okay. You can submit this infinite number of times. So, of course, I will be a harsh grader. Here's the rubric for it, and now that I'm doing this online, I'll put this online, but it's a basic rubric. Basically, any mistake, I'm going to take off 1 or 2 points out of 10, and you're going to get a C on 30% of your overall grade. That's not going to help your grade too much. So you want to turn this into a 10 out of 10 as soon as possible. So don't be alarmed when you get the feedback and I give you a 3 or 4 maybe, or a 5 or 6 out of 10 with some feedback, and by the discussion and whatever, you probably will have some ideas. You'll resubmit it. Maybe you'll get a 7, 8, or a 9, and then it'll be up to you on if you want to get the A in the class, if you're fine with more of a B or a C, and those kind of things, the decisions you'll make. Just jump right into it. So we go to citydata.com, and so that's this. Here's citydata.com, and it allows us to it gives us information. So we're just going to use this to get categorical data on a city, but you could use it to get lots of different information. So let's click on California, and let's just look at Antioch. It has lots. There's every city here, so you can find your city even in a different state. So it's kind of cool. Or let's say you wanted to live in New York, and you wanted to know what the ethnicity breakdown was in New York, or careers, or average life expectancy, whatever it is, you could find on this website. So here we go. It's the average male, female. It's predominantly female, a little bit more than males here, and so on. But here we go. Now we're at ethnicities. So these are the different ethnicities, and they've already made it into a pie chart for us. So all we're going to do is take this and copy it onto here. So if we come here, we can say we are going to look at categorical data called ethnicity. And for here we had Hispanic, we had white alone, black alone, Asian alone, and then we had 2 or more races mixed, and then we had like Native American, Native Hawaiian and API. We had other Pacific Islanders. We had American Indian and other races, but that was like 0.4%, so I'm not going to put those in. So here we had 31.5%, pretty high. Here we had 26.7, also very high. Then we had 20.9, which doesn't seem very high, but if you know African American population, that's pretty high. Asian also countrywide is, I don't know what it is. It's not 16%, so 16%. And you got to be careful here. This isn't, when you say Asian, it can mean a lot of things here. And so we have some awesome communities here who are not as prevalent, some Tongan communities and other communities that you might not see in other areas. So when you say Asian, it's not like a blanket statement, just like any race, of course. And then 2 or more or mixed races, it said 4%, and of course it's probably higher, but it's an emerging concept. So that's it. So we made this, and now we can draw the graph. I'll do a bar chart. We have here Hispanic, which was pretty high. We had white, which was a little lower. We have black, which was lower than that. And then we had Asian, which was lower than that. And then we had way at the bottom, we had 2+. So this was Hispanic, white, black, Asian, and 2 or more. We could label this races, because that's how it's labeled. And then the percentages. So I'm just going to write it. So maybe we'll call this like 30%. And we know 20% is right where we found the black ethnicity group. So that's at 20. And then at 10, that was kind of in between those two, which looks perfect. That's 10. So there you go. And if you wanted, you could put the numbers on here. Now this is done in a stylus, pretty bad, but yes, if that's all you wanted to do, fine. I would challenge you to do more. You could go into here and look up all sorts of interesting stuff. This stuff where you're seeing dates at the bottom or time at the bottom, don't go there. Those are bad news. That's a time series. Totally different thing, not going to be covered in this class. These are histograms. You don't want histograms, and these are weird histograms if you look at them. More time series, but here we go. Most common industries. This would be very interesting, especially for Antioch. Look at that, 10% construction. Yeah, of course. 6-7% finance, right? Healthcare, as you'd expect. Education's up there, though. So, if you're interested in education, and maybe ECE, early childhood, or this or that, there's some options for you in Antioch. You could make a bar chart out of this, and it'd basically be a copy of that. You'd probably just do it for Antioch, not include the California double bar chart, unless you wanted to be fancy. And I will end where if you make something look cool, something that, and you're uploading it and I can use it to show students instead of this boring stuff, like a really nice one with like glittery stuff and highlights and I don't know, some meme maybe if you're some other way of doing it. I mean, if you have some cool thing you've come up with, people have shown me some amazing stuff. A person made it all out of wood. I mean, a complete project that's out of wood is gorgeous. So I will give you extra points. I'm not going to turn you from an F to an A, but I don't think they did that for extra points per se, but they wanted to shine, show me what they got, and had a little time, so they did it. Then you want to write a paragraph. Now here's careful. This is where I wish you guys, I'm going to let you do it. But the key here is all you're doing is summarizing it from a categorical perspective. So if you're doing it from a categorical perspective, then what do you talk about when you see this? What are the things you're allowed to say or not say when you're talking about a categorical data? So that'll be worth a point or two that you could lose if you don't answer that right. And of course, you could resubmit it. Part 2, as you might have guessed, is the quantitative side of the flow chart. So what happens when the data are numbers instead of words, and we can make histograms instead of bar charts. Okay, so this link no longer works. We will now be going to the fastfoodnutrition.org website. So yes, choose any fast food that you like or restaurant maybe, and I want you to analyze it. So let's just choose Burger King. And what I want to do is I want to create 4 groupings and collect about 7 to 10 data points per group. So you can see here, it makes sense. We could have a burger group. We could have a beverage group. We could do a breakfast group, a chicken and fish group. Maybe not coffee, a desserts group. We could do salads, probably not. So a lot of toppings, and that's it. And sides. We could also maybe do a sides group if we wanted. So we're going to do 3 groups. So for you will choose, of course, if you had chosen a different company, Blaze Pizza, then right, you'd probably do, I don't know what you'd do. You could have drinks. It'd be different. I don't know. See, these are, I mean, you could do it. You could do it based on different types of toppings, maybe. The finishes. Different sauces, so it's up to you, but I'm going to do it with Burger King to make it because you could do it with a different fast food and get different data, and that's the whole point, right, is to get your own data and put it in there. We have chosen a group and we are going to choose Burger King, BK, and for our groups we're going to have burgers, and we had beverages. And then I think we were going to maybe do chicken and fish. I think we'll skip the breakfast and go right to chicken and fish. Now this is where it gets fun, because what do you put here? When I go to my Burger King, am I going to write bacon and cheese Whopper? No, I'm just going to write $7.90. Am I going to write bacon cheeseburger? No, I'm just going to write $3.17. $7.90, $3.17, $4.05. 1,147, 1,006 calories. Now we're going into, I guess, the smaller ones. Just a cheeseburger for $2.83, double cheeseburger. We're getting a nice diverse group, I think. Double quarter pounder is a big one. Then we go double stack king, it's big old burgers, and double Whopper. So I don't know, 890 to 1,002. So we'll just say 1,002 since we don't know what that means. Hamburger for $2.42, and an Impossible Whopper for $6.29. And finally, when we run out of space, we'll do the Quarter Pounder King for $5.80. So okay, yes, is this perfect? No. But we're not trying to be perfect. We're just trying to, collect some data, show that we know what we're doing, right? We have a research question. We're trying to find out how healthy these things are. Should we buy burgers, beverages, chicken and fish? How healthy are they? Well, these are the calories for burgers. Are these healthy or not? I don't know. Let's compare them to the other ones. But can you look at all these numbers and make sense of them? No. So we got to make a histogram. So now we'll do the same for beverages. And Minute Maid is 140. Okay, so there were more. So we're missing some of these. So yes, these last few aren't counted, and that's bad. We should put them on. I'm not too worried. We're just filling it up and moving on. Last one is chicken. And then finally, well, we fit every single chicken sandwich on here. Go us. So can you look at this and say, oh yeah, burgers are like at least 2.5 times more than the beverage, but only about 1.2 times. No, right? There's no way you can compare this. This just looks like one big mess. What do we need? A picture. Well, we make a histogram of all these data by finding the bin size. Exactly. So the smallest number here is about 242, and the biggest number here is 1147. All right, so 1147 minus 242 is 905. What is our bin size? Right, our bin size is the max minus the min over 7. And so we've got a max minus min of 905. If we divide that by 7, we've got 130. So here I'm going to make a judgment call. I'm going to round this actually to 200. And I'm going to round it to 200 because look at this. We're going from 200 to 1100. That if we go up by hundreds, that's almost like 1,000. We have to go up 10 bins. That's going to create 10 bins if I go up by hundreds. And 10 bins for only 10 data points, that's not smart. So because of that, I'm just going to go up by 200s. So this will start our axes. Instead of at 242, the floor of 242, rounded down to the nearest 200 is of course 200. So we'll start at 200, but then we'll have a 400, and we'll have a 600, and an 800, and 1,000, which will go up to 1,200, and that'll be it. We won't have anything higher. So from the 2 to 300s, we've got 1, 2, 3, 4. Now for the 4 to 500s, we've got 1, 2. And finally for the thousands and higher, we've got 1, 2, 3, 4, which is what we were expecting, right? We were expecting to get a lot at the top. Okay, what about beverages? So we do it for beverages and chicken and fish too. So I'm not going to do these because, I want you to try them. But if that's our table, now we can make a histogram for this. So if I draw the histogram, we're going up by 200. So to save space, I'm just going to write 200, 400, 600, 800, and 1,000. And we had 4 on the 200s. That's 1, 2, 3, and 4. And of the 4s, we just had 2. So we can kind of see how you go over. That way you keep them all together. It's a trick. And 6 is 2, so that just nicely goes over. 8 is a 1, and then of course 10 has a 4, and there we go is our bimodal graph. So this is bimodal, right? So this is not great. So if we were to analyze this graph here, I would want to say that that's bimodal. So we'd want to say bimodal, scary. Let's use the median and IQR. Okay, well, what is the median of these data points, Tua? Ooh, that's a pain to do. Or is it? We've got our calculator. Okay, so you've opened up your Wabbit emulator or some kind of an emulator, and now we're just going to input these data into the calculator to make a histogram. Now, of course, there's a million other ways to do this, and if you have a different way, then fine, but this seems pretty fast, and you'll see why. So we go to stat, because that's what we always do. Right, and then what do? We're just editing, so we hit enter, and now we enter the data. So 790, 317, and so on. And there's something about, going through adding the data. This is, I don't know, for good or for worse, this is like what going in and using a cadaver is like for a medical student. This is what, digging in the soil if you're in horticulture would be like, or this is what finally painting, or using real clay, making a big old sculpture would be like. Like actually using data, putting data in your calculator is kind of cool because you're actually doing something with it. Putting data in for art's sake may not be too cool, But for math, this actually signifies stuff. This is interesting. This is stimulating for me, and hopefully it is for you guys too, because it gets the mind going. And what are we but a mind? And a couple other things. Here we go. And I don't know. You guys might look back and see that I made a mistake here. Maybe I will see I'll make a mistake, although probably not. But it doesn't matter. You can put in any numbers you want. But the point is if you put in the numbers, whoops, I ran out of space. If you put in the numbers, see, there's a mistake. So 430, and then 912 goes down here. You could put them in backwards. I could put this one down here. It doesn't matter. It doesn't matter the order you put them in. How do we find the median and IQR of all of these data points? We go to stat. We've already got it in there. Remember? We already put it all in L1. So we just go to stat, we go to calculate. And what are we calculating? One of our stats on the first variable, L1, not L2. That was beverages, just L1. Bam, bam, bam. And do we need the mean? Nope. Standard deviation? Nope. What do we want? This 5-number summary. So now we can list the 5-number summary below. We have a min of 242. We have a Q1 of 352.5 apparently. The median is 629. The Q3 1004, and then the max is 1147. Okay, so that was kind of bad, right? I think you could maybe copy this and post it up over here. Sorry, but you're just copying this. And if you were really cool, you could either using a snipping tool. Just search for snipping tool. It's so cool. You just grab anything you want. There we go. Grab it, and then just copy, Control C, and then Control V. Bam. And you could just throw that in here and make it smaller if you wanted to. So you could totally do that. You don't have to, have all my sloppy stuff. You could have it here. Doesn't that look nice? Okay, guys. So honestly, that's kind of getting close to the end. So now you're going to repeat this again. So you're going to do it for the beverages. Remember, you only have 10 units, so 10 data points. So, starting from 3 and going up to 500, going up by 10s or 20s doesn't make sense. Maybe going up by 100 makes sense, right? Because you only want about 4, 5, 6 bins. You just don't have a lot of data points. And you can see we got a nice histogram here. If your histogram looks normal, then you should be showing me the mean and standard deviation. If the histogram looks skewed or bimodal or there's an outlier, then you should be using the median and IQR. So this is where students lose a lot of points. And I'll just say, hey, review the video. I'll be pretty, intense about it because you can get all your points back. You can make up all of the points lost. And then the last thing, and this is tricky, but you got to remember what your point is, right? There was a research question. And what was that research question? We were trying to find out, hey, I'm hungry. What should I order? Should I order burgers? If I'm watching calories, should I order fish or should I order drinks? And compare them. So here's where you would say things like, oh, the center for burgers seems to be between 350 and 1,000. So it's quite a wide range, but it was around 500-600 calories per burger. Whereas for a drink, which was, say it was normally distributed or something, it would have a middle of blah, blah, blah. Oh, that's much less. So that's what you want to talk about here, is you want to compare burgers en masse as a picture, burgers as a subject, compared to, in this case, drinks as a subject. And then say which one's better or worse based on your numerical analysis. And that, my friends, will complete your assignment.